Question 2, Part A. We want to solve 2x times x plus 4 is equal to 0. So this looks like a quadratic that's already been factorized for us. Now, two things multiplied together giving us 0 means that one of them has to be 0. So either 2x is equal to 0, and therefore x must be 0, or the contents of the bracket here, x plus 4, must be 0, which gives us that x is equal to negative 4. We now want to show a minimum spanning tree on the network below. So I'm going to use Prim's algorithm. I'm going to start with this vertex here and choose the shortest way to join another vertex. So that would be the 4 to here. I now want the shortest way to join either this one or this one to something else. So there's a 15, 11, 13, so it's got to be the 11 that goes to here. Now, we want to join one of these three vertices to something else in the shortest way. There's nothing we can join this to because we've created a loop here. So we have a choice of the 15 down to here, the 3 here, or the 6 here. So we're going to use the 3. We've only got two vertices left to join. So the shortest thing we can do now, 5, 6, 8 or 10, is going to be the 5. And then the shortest way of joining this one is the 8. Are the lines with equations y equals 3 minus 5 over 4x and y equals 2 plus 4/5 x perpendicular? Well, we can check by multiplying the gradients. Now the gradient is the number multiplying the x. So the gradient here is negative 5 over 4, and the gradient here is 4/5. So if we multiply those gradients together, we get negative 5 over 4 times 4 over 5, cancelling down, all of these become 1s. And that does give us negative 1. So the answer is yes. Evaluate 7 to the 4 times 7 to the negative 6, giving the answer without index notation. Now we're multiplying here, so we add the indices. So that's going to be 4 add negative 6, which is the same as 4 take away 6. So that's 7 to the negative 2. Using our knowledge of indice laws, we know that that's the same as having 1 over 7 squared. And 7 squared means 7 times 7, which is 49. We want to sketch the graph of y equals negative x minus 2, x plus 2 on the axes below. So that's negative x minus 2, x plus 2. If we expand the bracket, that would give us x squared minus 2x plus 2x, so those disappear, take away 4. And expanding out here, that's going to be 4 take away x squared. So when x is 0, y is 4. Going back to this form, we can see y is 0, so that's the x-intercept, so x equals 2 and x equals negative 2. And the fact this is a negative x squared tells us we've got a sad curve, so it's going to look something like this. Jean has bought 10 pots, each of which contain 5 seedlings, and is provided with data from previous experiments about the seedlings' likely survival in the pots. Data in the table below shows the relative frequency of seedlings in each pot that will survive for at least 1 week if they are not planted in the garden. In how many of the 10 plots can she expect more than 3 seedlings to survive for at least 1 week if she does not plant them in the garden? So more than 3 is 4 and 5. So that's 0.16 as the probability. So the probability applies to just one pot, but we have 10, so we'll multiply that by 10 and we get 1.6, and of course we can't have 0.6 of a pot, so we need to round up, and we'll say that's 2 pots. We need to look at this triangle here, and we're told that the angle BAC, which is this angle here, is such that the tangent of the angle BAC is equal to 2/3. This side AB we can see has a length of 600, and we want to find the length of BC. Well, we know that the tangent of an angle is equal to the opposite divided by the adjacent. So that's going to be BC divided by 600. But we're told that this is 2/3. So therefore BC divided by 600 is 2/3. And so BC is going to be 2/3 of 600. So divide 600 by 3, and that's 200. And then we get 400, in this case, meters.